So we're going to do the Iodination of Acetone Lab for Chem 1180. And here are all the components. I have unlimited glassware to work with, so I'm going to just have everything all at once here as opposed to what you do in the lab. But you can see that we have 4 50 ml Erlenmeyer flasks, one for each experiment we're going to do. We have 4 graduated cylinders for the 4 components that will be put into the reaction solution. We have acetone, water, iodine, and then hydrochloric acid. So we'll be filling each of these up according to the amounts that are shown in the table 1 of your lab procedure. Okay, so before we begin, you should know that I'm just going to be working through the lab, and I'm be explaining things as I go, but I'm not going to be explaining everything in detail. That's what the procedure is for. You should have that in front of you. When I find data, I'm not going to tell you where to put it in the report sheet. The report sheet shows you that, so you should be paying attention. And if I do anything repetitive, like I'm going to have to fill up each of these in turn, I'm just going to show the lab technique for filling one of them, and then the other 3, I'll just jump over that and go right to the reaction. So the video will be relatively short. Okay, so that's everything to start, and there's the waste container there, and my timer over on the right side there. Okay, so let's begin. All right, so for the first experiment, we're going to be adding in 3 mils of acetone. Get everything that needs to be here. There. So 3 mils of acetone. We got 6 mils of distilled water, so you should be checking your table 1. Six mils of water. So that we need a transfer pipette for that one. And then the iodine. Now the iodine is put into the reaction mixture last, because it starts the reaction. Oops. Been a lot of practice. Been a few months. Okay. Hydrochloric acid, we need 3 mils. You'll note that those amounts, the 6, 3, 3, and 3 add up to 15. It'll always add up to 15, so that when we double the volume, we always double the concentration, and that's what we're going to want to do. This is an initial rates method experiment. Put this over here. All right. And so, yeah. All right, so following the procedure, we're going to, let's see, get my stopwatch. Okay. And reset, okay. Now what we're going to need is some white paper. And what's happening here is we're going to be watching the color fade away. The iodine, what you can see is, maybe against here, as that orange color. And as the iodine reacts with the acetone, it's going to change, that orange color is going to fade away, and it should look like water when we're done. So we're going to time it and see how long it takes for the color to fade, which can be a little tricky to see. Hopefully we'll be able to tell I'll be able to tell because I'm here, but yeah, that should be okay. All right, so I have all the components ready. The last thing to go in is the iodine. Normally you wouldn't put big flags on on the graduated cylinders, but so you can see it. I think that's good to have. So here's the one. That's the last one. So we want to set that off. And then how you put in the others doesn't matter. I don't know if I say in the procedure which one to do. Probably just say put them in order. But in this case, I'm going to put the flag right there. That's great. Okay. So that's the acetone. And the reaction itself, that's in the intro to the lab. So if you have the procedure, which you should, in the lab write-up, you'll see what we're doing here. We're just reacting iodine with the acetone and the HCl. The H plus is acting as a catalyst. You can see that everything so far, mix it up a little bit. Everything so far is colorless. Yep. And now we add the iodine, and we gotta. So, what I recommend normally is you do everything the same way each time. It's gonna be off by a few seconds, as if you were to do this out several times. You'd be off a few seconds, but these reactions tend to take somewhere between 30 seconds and 2 minutes, so that's not a big deal. You definitely will. When you do the calculations out, they come out to be really good. Okay, so I'm gonna get ready here. Pour this in. Swirl it around, and then start. And do that the same way each time, so that adding and mixing will be the same amount in each. Yeah, oh, good. And you can see that it is definitely there. You can see, hopefully. Can't tell if, yeah, there it is. Not great. Should probably just use my phone, but you can see that and once it's mixed, you don't have to keep mixing it around. Sometimes students like to do that to just make them feel better, like something's happening. But as long as it's mixing, or they're hurrying it along. But okay. You can see, getting that long shot, and yeah, so I have it at that amount of time, 53.12 seconds. So that would be your first data point. So you want to put that in your report sheet. Okay, experiment 2. I'm going to add the acetone now. This is, if you look on table 1, in table 1 in the lab write-up, that this is going to be 6 mils of acetone. So we doubled the amount of acetone, but we're going to keep the total volume the same. So by doubling the volume of the acetone, we're doubling the concentration. The 6 mils of water is now 3 mils of water. That's how we maintain that 15 mils total. Don't do the iodine. And then the HCl remains 3, so we just double. All we've done is double the volume of the acetone. There we go. Where's my stopwatch? Set. Okay, we got the iodine, so I'm going to do it the same way. I'm going to add it in, I'm going to swirl it a few times and start the process here. So, oops. All right. In you go. Swirl around. Start. Swirl a little bit more. Experiment 2, doubling the volume of the acetone, and see how that affects the reaction rate. You can see it's fading pretty quickly. I'm gonna have to be really careful to watch here. And it is gone. And I have it at 21.86 seconds. If that's good or not. Got my glasses on so I can't see. I kind of see the numbers there. Okay, so all right. So that's experiment 2. And again, I didn't show the filling up of the graduated cylinders, and we're just going to go each time. I'm going to just do start from where the graduated cylinders are full, and we start the experiment. So that's experiment 2 with 21.86 seconds. Okay, experiment 3. And this time we have 3 mils of acetone. According to table 1, 3 mils of water, 3 mils of iodine, and 6 mils of HCl. So we've doubled the concentration of the HCl. So acetone in. Water goes in. HCl. This is one of the 6 mils. Okay, swirl this around a bit. All right, and then we're going to add in the 3 mils of the iodine and do the same thing. I've got this reset, it's all good. There we go. In. Swirl. And start. Okay, so the first experiment was 50-some seconds, and then the second one was about 22 seconds, and it should be about half of that. So I think the first one I wasn't, oh, gone, yeah. Might have jumped the gun, but I have it at 21:06. Got to stop blathering on when doing my experiment here. But yeah, and that's what we would expect for this, is actually that should be about the same as the second experiment. Okay, experiment 4. We have, for this, what we've doubled is the iodine. The iodine is 6 mils this time. So we have 3 mils of the acetone, 3 mils of the water, 3 mils of the HCl. It's got a little chip in it, so I keep thinking that's where I have to pour it. But there's the spot. Okay. And then, okay, so I'm set to go here. So and then we have the 6 mils of the iodine. In we go. Swirly, swirly. Start. And off we go. All right, so a lot darker, a lot more iodine in there. Looking, yeah, so you can see it pretty well. And I'm finally paying attention here. This is one that I'm pretty sure is the longest one, if I remember correctly, but that's why we're doing the experiment. Find out. So this one, it does seem to be fading. Okay. All right, 38. So once you have your numbers, pay attention this time. Almost there. Now normally we do out several runs of each, but for this, under these circumstances, we're just doing the one. Almost there. Just see it. I think I can. Gone. Yeah. So that is, I'm just going to say it in seconds. So it's 106 seconds 0.34. You certainly don't have to keep that 0.34. You don't have to keep the hundredths of a second for the time. Seconds will do just fine. I distorted the camera there. Yeah. So that's it. So we're just doing one run of each. Normally do 3 or 4 runs of each and take the average, but we're just going to go with that one run for each of the experiments. So now that you have your 4 times, you should be able to answer the questions for the calculations page.